All right. Definition of a derivative. So what we have here, f prime of x, is called the derivative of f. That's the first derivative. There's one prime mark right there. Prime mark. Some people put a little slash. Some people use an apostrophe. Whatever. How to find the derivative here? This is just slope. This is basically the change in y over the change in x. Okay? This is change in y values for 2 points close together. This is change in x values. And we're going to make the distance between those points get really, really small. So this right here is really just the slope function. That's all derivatives do. They find the slope of a function. Find the slope of f at a point. Up till now, we had to have 2 points to find slope. Now we're big kids, we can find the derivative at using a single point. We just got to use some limits here. All right, so we're going to use this definition to find f prime of x here. Now you may say, well, what point are we going to use for x, Mr. Kuhne? We're going to use just x for right now because once we get that function, we can plug any number into it. And that's why we would prefer these definitions as to this one. But we'll just start here for right now. So what I'm going to do here is use the definition. Limit as delta x approaches 0 for f of x plus delta x. Well, we know from Mr. Hankey that whatever is in here, I'm just going to plug in for x. So that's going to be x plus delta x squared plus x plus delta x plus 1. That is all that right there. Now we're going to subtract f of x. X squared plus x plus 1. All as the change in x approaches 0. So far so good. So I'm going to go ahead and FOIL this. So that's going to be x squared plus 2x delta x plus delta x squared plus x plus delta x plus 1 minus x squared plus x plus 1. It's big, it's long, it's scary, but oh wait, we can start canceling stuff out. 1 minus 1, got x minus x, got an x squared here, but I subtract off an x squared there. Well, holy crap, now I'm just down to this stuff right here. So 2x delta x plus delta x squared plus delta x, all divided by delta x. Now we got to take the limit with us technically. Well, I can factor out a delta x out of this whole thing and cancel it out. So that's going to give me 2x plus delta x plus 1 all over delta x. Because right now I still can't plug in delta x. If I do, that's going to give me 0 over 0, indeterminate form. But now that I've factored it out, I can cancel that. So now I have the limit of delta x, as delta x approaches 0, of 2x plus delta x plus 1. Now I can actually plug in 0 for the delta x, and get, this is annoying, 2x plus 0 plus 1. So the derivative of this f prime of x is just 2x plus 1. Now you may be saying, Mr. Kuhne, how does that help me find the slope? I can plug in any number now to find the slope. So if I want to find the slope of this function at 1, I could just say f prime of 1, just plug it in. It's going to be 2 times 1 plus 1, so the slope's going to be 3. If I wanted to find the slope of this function at 5, f prime of 5, 2 times 5 plus 1. So the slope at 5 is going to be 11. Okay. Now, if you don't like the delta x's because they confuse you, you can use h's. Okay. We're going to go ahead and do that with the next one here. Let me move this one out of the way. We're going to find f prime of x for this. So I'm going to use the second definition here, using h's. Limit as h approaches 0. So I'm going to do f of x plus h, so it's going to be square root of 2 instead of x, it's going to be x plus h plus 1 minus f of x. Well, that's just that function. That's all divided by h. All right, well, I can't plug in 0 here, because if I do, it's going to have 0 on bottom. It's going to become 0 up here, so it's going to be square root of 2x plus 1 minus square root of 2x plus 1. We get 0 over 0. Well, how do we deal with this? Conjugates. We're going to take this top one times the square root of 2x plus h plus 1 minus plus the square root of 2x plus 1. Same thing on bottom. When we do that, the top here is just difference of squares. So now we have the limit as h approaches 0 of 2x plus h plus 1 minus 2x plus 1 all over h times big huge thing down here, square root of 2x plus h plus 1 plus the square root of 2x plus 1. How does that help us? Well, 2x minus 2x, that cancels out. 1 minus 1, that's going to cancel out. I didn't distribute this here, so really I'm just going to have 2h on top. Limits h approaches 0 of 2h all over h times all this. And I'm not going to write that out at the moment. But the h's cancel. So now I'm not going to have 0 divided by 0 anymore. Limit as h approaches 0 of 2 divided by square root of 2x plus 2h plus 1 plus the square root of 2x plus 1. This is absolutely fantastic, because now if I plug in 0 here, I'm not subtracting anything, I'm not going to be dividing by 0. So I can go ahead and plug in 0 and get 2 over square root of 2x plus 0 plus 1 plus the square root of 2x plus 1. That's basically the same thing, so I'm going to have 2 over 2 times the square root of 2x plus 1. Those cancel out. 1 over the square root of 2x plus 1. So all that work to find f prime here. Why would we want to do all that? Well, this is a lot harder than the last definition up here. But the distinct advantage of this is I can plug in any number now. So if I want to find the slope of this at, if I want to find the slope of this at 1, it's going to be 1 over square root of 2 times 1 plus 1. It's going to be 1 divided by the square root of 3. I could plug in 0. And just get 1 over 1. Okay. The next thing we need to do is find the equation of a tangent line. Okay. So if I did have this function right here, square root of 2x plus 1, I'm just going to sketch it here. This isn't going to be exactly right. Let's say I need to find the tangent line right here. Okay. So I need to find the tangent line right here. You may say, why do you need to find a tangent line? Well, when Newton was doing this, he was trying to find out what would happen with planets here, okay? And if we had something spinning around the sun here, or you're swinging a ball around, okay? If all of a sudden the rope breaks right here, the ball is going to continue this way. And it's going to continue in a line tangent to what it was, to the curve at which it was moving here, okay? So that's why the tangent lines are important. Well, one of many reasons. We are no longer going to use y equals mx plus b. We are going to use y minus y1 equals the m times x minus x1. So let's say we had to find the equation of a line tangent to f at x equals, we'll go 2. That's the problem. We're going to use this right here to find our solution. So I got to find the y coordinate. That's not too hard. I'm just going to plug it in. I'm just going to plug it into my original equation up here. F of 2 is going to be the square root of 2 times 2 plus 1. So the square root of 5. The slope, we use f prime of 2. 1 divided by 2 times 2 plus 1. So it's going to be 1 over the square root of 5. That goes right there. X value is 2. So my answer is going to be y minus square root of 5 is equal to 1 over the square root of 5 times x minus 2. Do I need to simplify this? Absolutely not. Don't. Stop right here. Quit while you're ahead. This right here is one of the main ideas that you need to know. You need to know how to find the equation of a tangent line to a curve. Find equation of a line tangent to a curve. We'll put Mr. Hankey's top hat on it. And right there. All right. I'm going to take a pause here, let you catch your breath. We'll come back and do some more.